So day 2 of Unit 9, U substitution with definite integrals. Remember, definite integrals means there's an upper and lower limit or an upper and lower bound. And so you're not going to have a plus c on here. This is more like, hey, we can find the area under this curve from 0 to 1. If there's not limits on them, that's what we did all of yesterday. Those are indefinite integrals. Indefinite, part of the reason they're indefinite is you don't have a definite answer because they all have a plus c on them. So they're not definitely an answer. There's a plus c tagged on the end. For definite integrals, you don't have to worry about the plus c because you're going to do the top minus the bottom. So we've done definite integrals before, right? You take the antiderivative, plug in the top minus plug in the bottom. Yes? Remembering? So that part is the same. What's new is that we're going to still do some U substitution. Okay, so when we do U substitution, though, it's sometimes, in fact, I'm going to say usually here, usually convenient to determine the limits of integration, that's that upper and lower bound thing, the a and the b, in terms of U. Right now, like look at number 11, this is from x equals 0 to x equals 1. Because, of course it is, there's only x's in there. When we change this thing to x, or to u, we also have to change the limits. We need to change that upper and lower bound from x equals things to u equals things. So the extra step is, don't change all of this to u and then leave x limits. If you change this stuff to u, you have to change the limits to u as well. Yeah, I think I said all of this. The limits of integration you are given are in the variable you are given, right? So if this is an x problem, then that's x equals 0 and x equals 1. If you change it to u, then you actually do have a choice, and I'm going to make a preference here in a moment. You can keep the original limits in terms of x, and then put the x stuff back in. Some people like that because that sort of matches what we did yesterday. Like we put the x stuff back in, and then if we had limits, we could plug in, 0 to pi or whatever the limits are. And so if you plug the x stuff back in, you don't have to change the limits. What's usually easier is that you change the limits to u values and then use those without plugging x back in. Like you keep everything in terms of u. And the reason this one is preferred is because the AP test has a nice way of making sure that you do this. Like they can write a problem that forces you to do method number 2. So I'm almost always gonna do this second method because the AP test can force you into that method. So we'll talk about the 2 different methods as we go, but I'm usually gonna do method number 2. Okay. So again, the problem's all the same, except we got to switch the u limits, or the x limits into u limits. So first thing on number 11, what do you think would be a good pick for u so that du would show up and would simplify our integrand? Thoughts? Before I pick on somebody? All right, Ian, thoughts?
I want to say 1 minus x squared.
Good. Again, you want to pick u to be kind of complicated to make your integrand simpler looking, but not too complicated because then du is a mess. So you make it be a little bit complicated, but not too complicated. Okay, so du would be negative 2x dx. So far everything is the same. Like everything is the same as we did yesterday. So I need a negative 2 on there, which means a negative 1/2 out front. And then I've got the square root of u. I'm going to write that as u to the 1/2. And then all of this other stuff is du. Okay, all of that was exactly the same as yesterday. Where things change now is that I really can't put x equals 0 and x equals 1 here because this is a u problem, so I need u variables there, not x variables. So if you write 0 and 1, that's a wrong statement. And if I'm paying attention, I'll count off for it, even if you fix it later, because it's not true. If you're going to write limits there, they've got to be in terms of u. Okay, well, we know how to get from x to u. So the top limit is 1. So if I plug in 1 for x, I get 0. So that top limit was a 1, x is 1, but when x is 1, u is 0. So we're going to change that top limit to a 0 because we have to change it to u things. The bottom limit was 0. So if I plug in 0 for x, 1 minus 0 squared is 1. So my bottom limit is now 1. So I switched the limits from x limits to u limits. This one feels backwards. You want to do anything about that? How can we fix that? Flip it, and what price do we pay for flipping it? Yeah, make it negative or change the sign. It's already negative, so let's flip it. So let's make it 0 to 1, and that'll change the sign out front. And then increase the power by 1, divide by the new power. Don't forget the 1/2 that's still out there. And then I don't have to put it back in terms of x because I have limits with u. So I'm going to keep working this as a u problem. So let's see, 1/3. And then plug in 1. So 1 to the 3/2 minus 0 to the 3/2. And that would be a safe stop because that's all algebra stuff. But 1 minus 0 is 1. So my answer would be 1/3. Again, I did that the second way where I changed the limits because I just think that's an easier way to go. If you wanted to do it the other way, then once you get to here, once you integrate, then, and I guess some people do it the second way because it matches what we did yesterday. Like you replace the u stuff with the x stuff, which is fine, but then you would keep the original x limits, and you would end up with the same answer. It's just usually easier to go ahead and switch everything to u and just finish the problem out. All right, number 12. Again, the biggest thing is picking u correctly. So, Brandon, what do you think would be a good pick for u on number 12? Good. That will simplify the denominator without putting too much into the u. So then, Ian, what's du equal to?
2x dx.
There you go, good. 2x dx. So another one where we're close, but we need a 2 on there and a 1/2 out front. So 1/2 integral, but I'm not going to write the limits yet because I'm recognizing those are x limits, and I'm in the process of changing this thing to a u problem. So you can sort of skip it if you want, like just not write anything. That's better than writing 0 and square root of 5, because I'm still kind of cleaning up this thing. That's u to the negative 1/2. But I do need to convert those limits. So I'll spell it out a little bit clearer this time. If x equals square root of 5, then u equals square root of 5 squared plus 4. So that would be 9. So my upper limit is 9 now. And for the lower limit, when x equals 0, u equals 0 squared plus 4. So my lower limit is 4. So I change the limits from x things to u things. And now this whole problem is in terms of u, so now I don't have to worry about x's again. Let's see, increase the power by 1. Divide by the new power, so divide by a half means multiply by a 2, which is nice because those will cancel each other out. From 4 to 9, so 9 to the 1/2 minus 4 to the 1/2, that's a safe stop. That's an acceptable answer there. But that's also just 3 minus 2. So 1. Just as a reminder, this step right here would not be a safe stop. Right? Because that's still calculus-y stuff, that bar and those, like, you haven't plugged things in yet. So that's not a safe stop. Plug in the upper and lower, now you've got a safe stop, but you know that multiple choice is going to clean it up a little bit. So, very similar to yesterday with the extra thing of don't forget to switch the x limits into u limits. 13. Monty, he was here yesterday, so this is a little bit of a cruel thing to put you on the spot. I'm going to do it anyway. Any idea what u should be? Again, because we want du to show up. You've only seen 2 examples. Although it matches the other 2 examples pretty well.
I was going to say x equals 1.
That's right. So we'll let u be x cubed plus 1. Du then is 3x squared dx, which, it's a 4 there instead. So remember we had this happen yesterday. Just stick the 4 out front and put a 3 on there instead, which means you need a 1/3 out front. So you end up with 4/3. Let's see. And then the rest of that is square root of u du. So yeah, great pick on the u. We got an easy problem, relatively easy problem to solve. Why don't you see if you can finish it from there? Okay, so I switched the x limits to u limits. So x equals 2 is the orange one, the top one. So plug 2 in, you get 9. So that means 9 is now my upper limit in terms of u. The lower limit was x equals 1. If I switch it to u, it becomes 2. So my lower limit is 2. Integrate u to the 1/2, so increase the power by 1, multiply by 2/3. Clean that up. Plug in 9 minus plug in 2. This would be a safe stop. But multiple choice, they would clean up the 9 to the 3/2. That you could do. 2 to the 3/2 you're kind of stuck with. So either one of those answers is okay. Feeling okay with this? On 14. Kylie, what do you think? What do you think we should pick for you? Good. Cosine of x. So let's stick with Kylie. No, let's pick somebody else here. Rabia, if u is cosine, what's the derivative of cosine? Good, negative sign. Which is pretty good for what we want. We're off by a positive negative thing, so that's an easy fix. Again, you can fix constants and positives and negatives. If there's an x that shows up, you can't do that trick with x's. You can only do it with numbers. Let's see, this is another u to the 1/2 du problem. Right, because this negative sine x combined with dx, that's du. So now it's just changing the limits. So for pi over 2, cosine of pi over 2. Good, I saw one of these. Yeah, pi over 2, that's straight up. X coordinate 0. So yeah, so our top limit is now 0. And our bottom limit, let's see, when x is 0, u is cosine of 0, and the cosine of 0 is 1. Oh, another one where it feels like the order is switched. No big deal. We switch it back and change the sign. So 0 to 1, u to the 1/2 du. So that was a whole lot of work to get to this point. The idea is once you make it here, it should be easy. U to the 3/2 with the 2/3 from 0 to 1. Is this a safe stop? No, that's not a safe stop. Not a safe stop.
The next part is.
The next step is, 2/3 times 1 to the 3/2 minus 0 to the 3/2. And that's a safe stop. Like that can be simplified significantly, but it's not wrong. 1 minus 0 is 1 times 2/3 is 2/3, so that's a cleaner answer, but I don't know that I'd even say it's a better answer. I didn't hit record on the rest of that last problem. I don't think. Okay, so it's the same thing as yesterday. Don't forget to change the limits. That's the big thing. Is people do get caught up in the u substitution, and then they'll get down here at the bottom and they'll plug in u or 0 and pi over 2. So don't forget to change the limits. By the way, how the AP can ask the question and how we will ask the question is we'll ask which of the following is equivalent. And so we'll give you that as an answer, and then we give you 0 to pi over 2 as an answer, and then some other answers that wouldn't make sense either. But you can see where this answer would come from. They've changed the u's, but they didn't change the limits. They changed the integrand, but not the limits. And so that's how we can test to make sure, sort of force you into changing the limits. You can also do it this way, and then you don't really have to work the rest of the problem if we stop there. So those are good problems too. All right, worksheet 2 is the assignment. I'll be pass that out.